Hello everyone, let's solve this problem LeetCode103. Okay, so the binary tree zigzag level order traversal. Let's see the direct description of this problem. So given the root of a binary tree, return the zigzag level order traversal or of its nodes value. So from left to right, and then right to left for the next level, and then alternate between. So that means we start from left to right for this level, and right to left this level, and left to right to this level again. So this basically what we do for this problem. Okay, so for this problem, what we do, we are going to use the data structure queue, the first in first out. Okay, let's give this example. Okay, so this is the example here. So what we do? So first we will create a queue. It's first in first out. We use a linked list in this case because we are going to traversal this one from left to right and right to left. So it's very similar of the binary search level order traversal. You remember in the previous video. So we just do the iterating every single level. Like this one is a 3, and the second level is left to right, and the third level is left to right too. Up to bottom or bottom up. So but for this problem, we are going to do a zigzag level. So that means in this level, we start from right to left. If we start from right to left, when we create our level, we use linked list. Because we use a linked list, we can add first to the result. When we use add first, if we use a linked list, we just need on time complexity. Okay. Okay. So what do we do for this problem? So first, we will offer our root to this queue. So in this case, our root is 3, right? We will offer this one, and then we will check if the queue is empty or no. So in this case, it's not empty. So what we do, we have the level, okay, and then we will check the size of the queue. In this one, the size of the queue now is 1. Okay, so it's 1. And then we will pull our nodes out. So we will pull the 3 out. And what we do, we will check the, we will have another one. This one is called the left to right. So this one is Boolean variable. By default, we make it a true. Okay. So when it's true, we will add from left to right. So in this case, is 3. After we pull 3 out, and then we just add to the level in left to right, this level. And then we will check if the node 3 have left child or right child. This one have left child. We offer the left child to our queue. And then we will check the right child. In this case, we have right child. We will offer 20 to our queue. Okay. After we check, we just add the after we check the left child and right child and offer it to the queue, and then we copy 3 to our result. Okay. Our result is a list of list. Okay, so what do? We just copy this one to our result. Okay, this is the first step. Okay, after we copy to the to here, and then what we do, we will check this queue is empty or no. So in this case, it's not empty. So we will record the size. The size now is going to be 2. Okay, so we have 2 here. So we record the size is 2, and then we will new another level. The size is 2. Okay, so what we do, we just pull this out. Pull the none out. And then we will check this one left to right is true or not. Okay. In the previous step, after we copy the level 3 to our result, and then we change our left to right to false. Okay, so now the left to right is false. It's in previous step. Okay, here is a false, and then we put the none out, and then we will check the left to right is false or wrong. So this one is false. So what we do, we add first, because here right now it's empty. When we add first, we add front of the none. Okay, so it's none. And then we will check if none have left child or no. So in this way, we don't have left child, so we don't have to offer anything to the queue. The right child of none, we don't have a right child of none, so we don't have to offer anything to it. And then what we do, we will pull this out, pull the 20 out. After we pull 20 out, we just checked the left to right. Right now is false. So if it's false, we will offer the we will add the 20 in front. Add first means that it will insert 20 from the front. Okay, add first. That's front. Okay, so it's gonna be like this. Okay, 20 and none, because here left to right is false. So we are doing right to left now. So and then we will check if the 20 have left child or no. In this case, we have left child 15. So we put the 15 in our queue, and then we will check the right child of 20. We have 7 here, so we put a 7 here. Okay, we offer the right child to the queue. And then what we do, we will copy this one to copy this level to our result. Okay, we will copy this to here. And then we will set the left to right to true. Okay, so what we do here, so we will set this one to true. And then we will check if our queue is empty or no. So in this case, it's not empty. And the size of the this one is going to be 2. It's going to be 2 again. Okay. And then our level is going to be 2. Okay. So and then we will do what we do. We will pull this one out. We iterate our size is from 0 to 1 because we have a 2, right? So we pull this out, and then we will put we will check left to right is true or false. Here is true. Because it's true, we just add 15 here. And then we will check if 15 have a left child or right child. In this case, we don't have a left child and right child, so we don't have to update. We don't have to offer anything to our queue. And then we will pull this out. After we pull the 7 out, and then we will check if the left to right is true. Yes, it's true. That means we are going to put this one after the 15. If it's false, okay, we will put a 7 here. Okay, but in this case, it's true. So in this level, we are doing left to right. Okay, it's true. So we put a 7 here, and then we will check 7 have left child and right child. In this case, we don't have a left child and right child. And then what we do, we will copy this one to our result. Okay, after we copy this one to our result, we set this one to false. Okay, after we set this one to false, we will check if our queue is empty or not. So in this way, it's empty. So our while loop is end. Okay, is stopped. Okay, and then we return this result. So this is basically the algorithm. Okay, let's start coding. So what we do here, so first, what we do, we will new a list of list. The data type is a integer, and we call it a result. Okay, so it's gonna be list of integer here. The name is result. Okay, and then we new an array list. And then this is a corner case. We will check if our root if equals to none or no. If equals to none, what we do, we just return the result. Simply return the result. And then we are using the queue is for our data structure. Okay, so this tree node queue. And in here, we are using a linked list. We cannot use array list. So the reasoning, okay, so because we are doing traversal from left to right and right to left, and when we add the add this element to our level result, what we do, we add 20. We add 20 in front of none, but when we traverse none, and then add none to our level. And then when we when we add 20, we add 20 in front of the none. So add first. So we use a linked list here. But if we use array list, let's say, if we do this operation, so our time complexity will be O(n). But if we are doing linked list, our time complexity will O(1). So here we are using O(1) to implement this queue. Okay. Okay. So what we do now, we will define this Boolean variable left to right. Okay, so because our first level is the root, right? The root we are doing left to right, so it's 2. And the second level we do this way, right to left, and then it's gonna be false. So and then what we do, we offer the root to our queue. What we do, we offer our root to this queue, and then we will have a while loop. Okay, we will check if our queue equals to is empty. Is empty. If it's empty, let's say, if it's empty, so what we do first, we will get a variable size dot queue dot size. Okay, and then we clarify the linked list. Okay, there's an integer in the linked list, and it's level. This we will store every single level of the element, the tree nodes here. Okay, so we will define this one, and then we will do for loop. So for the for loop, I equals to 0, I smaller than the size, and I plus plus. Okay, so what we do, we have a tree nodes equals to queue dot pull. Okay, we will pull the in the first level, we will pull the root first. After we pull the root, we will check in which order we will do. So this is left to right. So this one, if left to right is true, we will do we just simply add the node to our level, use our normal order. Okay, so it's level dot add node dot value. Okay, so if it's false, we are doing right to left, right? So when we do right to left, we else level dot add first. Add first, okay? Node dot value, okay? I just showed the example how this works, okay? And then we will set the left to right to false later, okay? And then what we do, we will check if the node dot left not equals to none. If not equals to none, what we do here, we queue the offer node dot left. Okay, and then we will check if the node dot right not equals to none. If not equals to none, what we do, we queue the offer. We do no node dot right. We will offer the right child of the node to our queue. Okay, this is basically what we do. After we finish this for loop, we just do result dot at level. Okay, and then we will set the left to right. Set this one at false. Left to right. Okay. After we finish it, what we do, we just simply return the result. Okay. Let's run the code. Okay, it's accept. Okay, let's talk about the time complexity for this problem. The time complexity for this problem. It's gonna be O(n) because we iterate every single tree node from the up to bottom, from left to right, right to left, right? So we just did once. Okay, so the space complexity for this problem is gonna be OW. So W is what? W is the max of length of the level. Okay, so in this case here is 2. So OW is going to be O2. If this one, if none have left child and right child, so in this level going to have 4. So the maximum length of level is going to be 4. So the W is 4. So it's going to be O4. Okay. Let's submit the code. Okay, our code is 100% faster than the Java Online submission. Thank you for watching. I'll see you next time.